Hey everybody, welcome to Algebra 1-2, Section 9-3, Part 2, Solving Quadratics by Square Roots. So the first part of Section 9-3 we've already covered, and that was solving quadratics by the graphing method. So of the four different ways that we're going to learn, the graphing method, the square roots, factoring, and quadratic formula, we've already covered the graphing, and now we're hitting square roots. So by the end of this lesson, you should be able to use order of operations to solve quadratic equations by square roots. You need to be able to recognize when there's no solution, and you need to be able to use square roots in story problems. So in solving quadratics, we've already talked about the four different kinds. They're solved by graphing, we've already done. And so it's where you graph the parabola and then basically see where does it hit the x-axis. Okay, we're covering square roots now. And then in future lessons, we're going to cover solved by factoring and quadratic formula. So here's three different quadratic equations. What do you notice is true about all three of these? Okay, there's several different things. First off, they all have x squared in them. Well, that's what qualifies them to be quadratic. They've all got an equal sign, which is what qualifies them to be equations. But what else do you notice about this? What do they all have in common? Or rather, what do they all lack? Okay, so a quadratic can be written as ax squared plus bx plus c, but if you notice, all three of these lack a b term. Okay, so in order to use square roots, you can't have a b term. You can have an x squared term and you can have a constant term, but you cannot have a b term and use square roots. So let's go ahead and take a look at this first one. X squared equals 144. Now, what we're going to do is we're going to use order of operations, which most time we think of PEMDAS. Please excuse my dear Aunt Sally. And that's great for when you have an expression and you want to kind of simplify it down to just one number. That's exactly what we use. However, in solving equations, we use the opposite order of operations. So instead of PEMDAS, we use SADMEP, which tells us take care of subtraction and addition first, then multiplication and division, then exponents, and save any parentheses till last. So, in this case, the only thing that's hanging out with that x is the squared. So how do I get rid of the square that's on the x? Well, you may know this already, but the way you get rid of a square is to do the square root. So what I'm going to do now is I'm going to go ahead and take the square root of both sides. So now I've got the square root of x squared equals the square root of 144. So the square root of x squared, that just turns into x. And then the square root of 144 is 12. Now, you might just see that 12 and negative 12 both popped up on the screen. That's because the original equation, x squared equals 144, there's two numbers that when you square it, it turns into 144. So 12 times 12 is 144, but also negative 12 times negative 12 is also 144. So when you're the one doing the square root, you have to be aware of both the positive and negative version of the answer. So another way we can write this is with that funky little symbol there, and that just means plus or minus 12. It means both the positive and negative version of 12. Let's go ahead and take a look at the purple problem. So 3x squared minus 50 equals negative 23. First thing I want to do there is, I got lots of things I need to get rid of. I need to declutter that left side. I've got the 50, I've got the 3, I've got the square. All those things need to go to get x all by itself. So our reverse order of operations says take care of subtraction and addition first. So I'm going to add 50 to both sides. So now I've got 3x squared equals 27. Next, I take care of multiplication and division. So I divide by 3, and I get x squared equals 9. And then I can deal with the exponent. So to get rid of that exponent, I take the square root of both sides. And the x squared turns into just x. And the 9 turns into plus or minus 3. So far, not too bad. Let's go ahead and take a look at the blue problem. Similar idea as question number purple, as the purple problem. All right, so first thing I'm going to do is I'm going to subtract the 10 from both sides. Then I'm going to divide by 2. And now I'm going to take the square root of both sides, so the exact same steps. However, the square root of 67 is not a perfect number. So what I end up getting is, when I take the square root of both sides, I get 8.18535. Well, my rule of thumb is to round to 2 places, so I'm going to round that to 8.19. Okay, and that's my answer. However, I can't forget both the positive and negative version of that, so I make it plus or minus 8.19. So with square roots, it's not a guarantee that you're going to have a whole number answer. All right, let's try a few more. Next problem, we have x squared equals negative 49. So very similar to what we did on the very first problem on the last screen. So I take the square root of both sides, and when I do that, the square root of x squared, that just turns into x. However, when I take the square root of negative 49, your calculator should say something like no solution or domain error. That's because it is impossible to take the square root of a negative number. Now, when you get into Algebra 2, you get into like something called imaginary numbers. Like algebra is not hard enough. Okay? But for what we're doing right now in this class, you can't take the square root of a negative number. Okay? And if you think about it, what number times itself gives you negative 49? There isn't one. Okay? Because positive 7 times positive 7 is positive 49. Negative 7 times negative 7 is also positive 49. So there's nothing that works that gives you negative 49. Let's take a look at question number purple. All right, so first thing I'm going to do is I'm going to subtract the 143. And when I do, I get negative 80. Next thing I do is I divide by 5. And I get x squared equals negative 16. And I think you can see where this is going. But when I take the square root of both sides, the x squared turns into x. And the 16 comes across as no solution. Well, I kind of jumped the gun a little bit on the next problem, but here we are. So, first thing I did was subtract the 18 on the blue problem, and I got negative 6x squared equals 90. Next, let's divide by negative 6, and I get x squared equals negative 15. And I'm pretty sure you know what's coming up next. Once we take the square root, okay, the x turns into x, but the square root of negative 15, can't do it. It's no solution. So what I want you to get from this is it's not really easy to look at the original problem and tell it's no solution. You need to wait until you get x squared, or better yet, get x all by itself. And if you're taking the square root of a negative number, then that's when it's no solution, okay? So here's a couple other examples, and there's a point to these. So some people might look at this and say, I see a square root of or negative 49 over there. So because the 49 is negative, it's no solution. Well, like I said before, wait until you have x or x squared by itself before you make that determination. Because what I'm going to do now is I'm going to go ahead and I'm going to add 74 to both sides. And when I add 74 to both sides, I get x squared equals 25, which is a perfectly legitimate problem that we can do. Okay, so let's go ahead and do that. Square root both sides. And I get x equals plus or minus 5. Okay, so at first the problem looked like it was going to be no solution. But as we worked it out, we figured out that was not the case. Likewise, some people might look at this and say, oh, it's all positive numbers. Yeah, we can do this. But check out what happens. If I subtract 14 from both sides, I get x squared equals negative 4. And right there I can tell that even if I take the square root, it's going to be no solution. So the point I want to make here is it's very difficult to just look at the problem from the beginning and say no solution or not. Work it on out as best as you can until you get the x squared or the x. And if you're dealing with a negative number then we can determine it's no solution. Now we have some problems that don't look too dissimilar from what we just did, except there's parentheses involved. And if you recall from our order of operations, we do our add and subtract first, then multiply and divide, and then exponents, and we save the parentheses till last. So a way that I like to think of it is the parentheses are like a force field, and you can't touch what's in the force field until the parentheses are gone. So what you're going to do is you're going to try to get rid of everything outside the parentheses to lower that force field. And once that force field's lowered, then you can deal with what's inside. So let's go ahead and do that. So on the outside of the parentheses here, I have the squared. Okay? So in order to get rid of that square, I'm going to take the square root of both sides. So when I do that, the square root and the square go away, and I get x plus 3 equals plus or minus 11. All right? Now, at this point, there's nothing outside the parentheses, so there's nothing holding those parentheses there. So it's okay if we get rid of the parentheses at this point. Once we do that, the only thing left with the x is that plus 3. So we have to minus 3 from both sides. Now, I'm about to make a mistake, and follow me on this. When I subtract 3 from both sides, on the left-hand side, I get x. When I subtract 3 from the right-hand side, a lot of people will say, oh, well, 11 minus 3 is 8, so it's plus or minus 8. That is the way wrong thing to do. Okay? Now, I like the idea of subtracting 3. That's not a bad idea, but the issue is we're dealing with positive and negative 11. Okay? So a better way to visualize this is to take that plus or minus 11 and split it up into two separate numbers. Because when you subtract 3 from each of those, it works a little bit differently depending on if it's positive or negative. So I took the plus or minus 11, split it up into plus 11 and minus 11. Now I'm going to subtract 3 from all 3 spots. So on the left-hand side of the equation, I just get x, and then 11 minus 3 is 8, but negative 11 minus 3 is negative 14. So I get two different numerical answers there. Okay, it's not positive and negative 8. All right. Another way you could write that is x equals 8 comma negative 14. Again, looks like I kind of jumped the gun on the next problem, but let's just roll with it. So, based off the original equation, I've got a couple things outside the parentheses that I need to get rid of first. So I got to get rid of that 2, the square. I got to get rid of the 12. First thing I did was get rid of the 12. So I subtracted 12 from both sides and got 34 on the other side. Next thing to get rid of, after we do our subtraction and addition, let's get rid of the multiplication and division. So I'm going to get rid of that 2 by dividing by 2 on both sides. And now I can get rid of the square. So I will square root both sides, and I get x minus 5 equals plus or minus 4.12. Square root of 17 is not a whole number, so I rounded it to 2 decimal places. So the next wise thing to do would be to take that plus or minus and split it up into 2 separate numbers. So I'll have x minus 5 equals positive 4.12 and negative 4.12. Let's add 5 to all 3 spots. And then I'll get x equals 9.12 and 0.88. So again, 2 very different numbers. So make sure you split it up into 2 different numbers so you don't get plus or minus 9.12. Okay? So if your problem has parentheses, this is a big shortcut here. If your problem has parentheses, you should not have plus or minus in your final answer. If you do, you did something wrong. All right. So let's take this and let's apply it to story problems. So what we're going to do is we're going to read the situation, turn it into an equation, but I think it'll be a lot easier than what you think it is. So let's say you have enough paint to cover 120 square meters of surface. If you painted the biggest square you could paint with that paint, what would be the length of the side of that square? So I'm a visual guy. Let's go ahead and get a visual on this. Let's say we have this big blue square and the area is 120 square meters. Well, it's asking what's the length of the side of that square. So I just put an X on one of the sides. Well, because it's a square, if one side is X, the other side is X too. So if you know your formula for area of a rectangle, it's just length times width. So I can come up with the idea that x times x equals 120. Well, if x times x equals 120, x times x is x squared. Now it looks like what we were dealing with before. So to get rid of that square, let's take the square root of both sides, and then we get x equals plus or minus 10.95. Okay? Now, this is a story problem. This is a real life thing that could possibly happen. Would it make sense to have a square with the length of negative 10.95? No, it wouldn't. So in this case, it doesn't make sense to take both the positive and the negative version of this answer. So I'm going to be fine with just x equals 10.95 meters. Well, that's our lesson. And again, in order to use square roots, you can't have a b term. So there's going to be lots of different questions that we can't use this method on. Okay? But it's good to know it because it is, of the four methods, one of the easier things to do. Okay? So if you guys have any questions, please feel free to reach out to me either via email or ask me questions in class. I hope this wasn't too bad for you, but I will see you guys real soon. Have a great day.